Welcome to the Lab 3 demo. In this lab, we are taking our data skills that we've built so far and applying them using linear regression, ordinary least squares, and actually trying to learn something more than just learning data. So the data set we're going to work with is called graduation. The reason it's called graduation is that it's from a study of graduation programs, specifically a randomized control trial that I implemented with a bunch of co-authors in the Philippines. This is pretty early stage data. It's a little bit messy, but I like it because it kind of shows you sort of what data looks like. Essentially what we did here is we had a study that was trying to measure the impact of graduation style programs. And what I mean by this is social safety net programs that provide supports to super poor households in a lot of low and middle income countries. These have been really successful. There was a big paper that came out in 2015 showing that when you did programs that gave people some cash to provide stability, a one-time asset transfer like a goat, or some money to go start a business, training, and then regular coaching and mentoring, this had really big effects both in the short run, medium run, and longer term in terms of helping households get out of poverty. That initial study was in a whole bunch of countries, Honduras, Ethiopia, Bangladesh, 3 more I don't remember, and found really robust effects across the board, except for one site where everyone invested in chickens and they all got sick and died. But in general, it worked really well. And so this study is in the Philippines, and we're looking at ways to make this program more cost effective. So what you can see is that there are different treatment arms. We have a whole bunch of people here. You can, it's always a good idea to browse and look at the data. You can see there's thousands and thousands of people here. They're in all these different municipalities across one area of the Philippines: Talisay, Victoria, Silay City, Murcia. These are the villages. And we have all sorts of information here: their gender, their age. These are all in Western Visayas, in Negros Occidental. And we can see all sorts of information in terms of their outcomes. So basically, this is a data set that we can use to see, did these program variations work? To understand what the program variations are, we want the treatment variables. If you can't find them, they're right here. If you can't find them, you can always look for them. So for example, if I'm not sure what variable I want, I might look for treat. You can't use asterisks or anything like that, but this will help. It will search both the name and also the labels. Treatment arm is the one I want. And what you can see is there are some people who were assigned to a control group. They didn't receive any additional supports. They were part of a cash transfer group, so they got some monthly money through the government. This group received the graduation program with the package of supports. They were asked to do their livelihoods in a group, and they also received their coaching in a group. So instead of someone coming to their house and meeting with them once every other week, they went to a central location. They might learn from each other better. They might have less accountability, might be better, might be worse. It's definitely cheaper. This was their individual livelihood and group coaching. And then this was that they got their individual livelihood, the support to run their own business on their own, and their coaching was done on their own. This is essentially sort of like the standard practice, and this is the most expensive one. So these are our treatment assignments. We're going to play with these, but one thing to note is that I can't really do anything with these, right? So I can't like count if treatment arm equals control, because as you can see, this is a byte variable, meaning it's a single digit, and these are letters, and so it's not a string variable, so it's not going to work. If you're not sure what's going on, you can always browse your data and go to treatment arm, and you can see that it's blue. That means it's a labeled variable, so you see the label, but up here is the value, and the name of the label is right here, treat. So there's a few ways you can get around this. One is you can manually just look at it. So I could, for example, instead of this, I could go here, I could see control takes a value of 0, and I can do that. You can see that's the same here. Or what I can do is I can turn off the labels. That works. I can also list the labels, but the important thing here is that you have to make sure you use the name of the label, not the name of the variable, and that can be a little complicated because you need to get it from over here. Another thing, if you're feeling a little more advanced, is there's a nice package you can install if you're comfortable with packages. And the package is called free, like frequency. And then once you've installed that, it stays there forever, not just your session. So it's not like R, you can keep it forever. Then you can do that and you'll see both the label and the number and the distribution side by side. Other things that might be helpful is you can also code book it. And that's also will give you the numbers and labels side by side. So Stata is nice because it gives you lots of options, but it will also drive you crazy because there's lots and lots of options to sort through these different sorts of things. But what you can see is people were assigned to different types of treatments, and then we can look at some of their demographic characteristics, and then we can look at some of their outcomes. This was from a phone survey we did about halfway through. There's also a paper, which if anyone's interested, I'm happy to share. We ended up pooling our results with 2 other study sites, one in Uganda, one in Bangladesh, where we were all testing the same things. So what we're going to do in this lab, now that you have some sense of the context and the data and what is happening, is basically estimate some simple 2-variable linear regressions. We're going to use variables that are continuous, variables that are binary. We're going to look at them. We're going to do predictions, look at residuals, read output. I have some reminders here about how to read a regression table. Most of these things you should hopefully already be familiar with in terms of identifying the estimate on beta 1 hat, the standard error for beta 1 hat, the estimate for beta naught hat, the standard error for beta naught hat, and the associated t-values and p-values, T statistics and p-values. But our TSS, ESS, and SSR are all in here. They're a little bit hard to see sometimes, so I labeled them so they'd be easy reference for you. What you're going to do, I recommend, is rather than just messing around in the command window, you want to go back to your template, open it up. You might have your old lab in here. That's fine. What I would do is I would just duplicate it. And then I would just start deleting the things you don't need. We still need that directory. We want to use our new file. Remember, you can run one line at a time, or you can run the whole thing. You want to have a new lab log that's just for us, and then put our commands in here. What you're going to want to do is use some key commands that we should be familiar with. For example, we might want to count our observations. We might want to tab our treatment arms. We talked about those already. This lab focuses on food security. What I mean by food security is whether people have access to both enough food and also a reasonable amount of dietary diversity. For folks who are super into this stuff, I'd love to geek out with you more. We, in this survey, did not use a standard food security index. There are some cool ones, the HFIAS and the dietary diversity score and the food consumption score. There's a whole bunch of different ones you could use. Because we were trying to do a really quick phone survey during the pandemic, we were really limited. So we tried to cover the number of days you limited portion size, reduced meals, reduced the kinds of food. We looked at the amount of rice and meat you ate on the number of meals with meat, because meat is going to be a luxury for a lot of folks, and whether their food expenditures went up, mainly due to inflation. So what you're going to do is play with these variables. You might rename them. You might drop observations with missing values. We're going to build some scatter plots, which hopefully you're comfortable with, and calculate t-tests. These sorts of things are going to be something that I can demonstrate a little bit, but you can also work with your own variables. So let's say I'm interested in FSEC1. This is going to be the number of days with a limited portion size at mealtime. I know that because it says it right here in the label. I can also summarize FSEC1 to get some information, and I can describe FSEC1 to get that full label in terms of the definition of the variable. So this is a variable that has ranges between 0 and 7, which makes sense. It's an average of 1.51. That should make sense. You can see that there's non-missing observations for all but 1. I'm going to generate a new variable just to make it a little bit easier for me, because I don't want to stick with FSEC. So I'm going to rename FSEC1 food security just for our own purposes. I'm going to tab it. and I can see the distribution. You can see about 13% had to limit their portion size all week long. This is a very poor set of households. And I want to check for missing observations. You can see that there's one missing, right? We saw that already. The other way you can do this is by adding missing, or you can abbreviate it MI. You can see one person has a missing code, .d, that means they didn't know. We can drop this. There's a few ways we can do this. We can drop if food security equals .d. I prefer to do it this way. Missing food security, that basically gets rid of all the reasons it could be missing. It's a long way of saying you can have a dot for a missing code, but you can also have a .d, .r, .s, .a, like there's lots of different missings, and so this kind of takes care of all of them. Now we can see that the number of observations matches the ones for which we have valid observations, so that's good for us. We're going to graph and make a scatter plot. And I can see that I want to make a plot with graduation. Now, one thing that I didn't do was I didn't really pay any attention to what graduation means. I just typed it, and I've got this kind of wild graph. So what this shows is that there's this distribution over here, there's this distribution over here, and there's lots of observations. They're all stacked on top of each other, so that's not great. So we might want to play around with that. We're definitely going to want to calculate the correlation. We can see that it's negative. That's probably good. But we also don't even know what graduation is. I just typed that because I just came to my mind because it's called graduation. So that just means that they received some graduation. But if we tab it, you can see that it basically means whether they received any of these programs. So basically, if you received any of these programs, there's a negative correlation between food security and whether you received these programs. But the figure itself is kind of hard to interpret. It doesn't really make a lot of sense to us. So then we might use simple linear regression. And our dependent variable here is the outcome, right? And the independent variable is graduation. And now what we have is an actual coefficient. What this means is for you to figure out, but we can enjoy it here. And we have some t-statistics. And we can also calculate a t-statistic using a standard t-test, which if you go back up here, oh, we didn't do that. Well, then I guess you'll have to follow my footnote. Follow my footnote. And you can do that and take a peek at that. Then the other thing we're going to do is try to predict some information. We're going to, after we run this, we can predict. This is going to be the predicted variable of our food security. We can type it like this, or we can type it like this. XB is default. What this does is it gives us a predicted value based on graduation. And so if we tab it, you'll see there's one predicted value when you don't have graduation and one predicted value when you do. That should make sense because we only have a variable that shifts on or off one. Then the other thing we might want to do is generate our residual. And here we're just going to type residual or resid. And remember, this is going to be the difference between the individual value and the predicted value for every observation. Because there's only 8 potential values, 0, 1, 2, 3, 4, 5, 6, 7, and graduation or not graduation, there's only so many options that we're going to get here. We're going to have you examine the predicted value for your youngest food security variable. For the youngest person, you can click on this for a little bit of a hint. That'll help you there. And then the last thing I want you to do is playing around with the variables after you estimate it on a constant. And so enjoy that as you dig in. My hope is that this covers both the background that you need and a lot of the key comments, but note that I did skip through a bunch of the questions in here. So this is not comprehensive. You're going to need to play with the standard errors, do your own playing with the data, and then make sure that you've put everything into a do file. I didn't. If I wanted to, and I messed that up because I was having too much fun, I might go over here, I might hold Shift and select them, might right click and send them to my do file editor, and then I might just paste them in here. This isn't great, but it will run as long as I don't mess up this, which I've already done, and it will get the job done. So any questions, reach out to me, reach out to Ray, a friend, etc., and good luck.